So we will go now to our next speaker, Sandor Brockhauser from Humboldt University, Berlin, FAIRmat for material science to follow FAIR principles.
Thank you. Thank you very much. I hope you can hear me.
Yes.
Have a good afternoon to all of those who are sitting on this side of the ocean. Actually, we've been already speaking about different communities, synchrotrons, free electron lasers, bioimaging, microscopy, and actually what I'm bringing now to you, this is a different community that's about material science. And the question is how we can take advantage of ADH5, the presence of ADH5 or Nexus as a kind of ontology or annotation, how we can use, for example, HDF5. FAIRmat, it's a new project which is just starting right now. It's within the German landscape, within NFDI, which is the German National Research Data Infrastructure. Last year, it has been started with 9 projects sponsored, and this year we are going to have 10 more new projects starting. One of them is FAIRmat, which is a 5-year project. 9 institutes Germany-wide, and indeed 52 different research groups, all about material science, with a budget of about 20 million euro. And the idea is to get all these institutes come together, all what's available, the different data structures and data sources, bring them together in a way so then it becomes fair, open science becomes possible. So it's I can take advantage not only just the data I have computed or I have collected, but also that has been collected or computed by others. We are not starting from scratch. Actually, within material science, there was already a long phase of getting people from the different corners coming together. And indeed, those who are working on the field of synthesis or experiments or theory, simulations and calculations, they were coming together already beforehand. And they have already established and understood what is the need, what needs to be done actually to be able to be to go to the next level of interoperability. So then we can really take advantage of the data what we are just producing. One example for this is when someone performs an experiment, and then how we can take advantage of previous hypothesis and previous simulations that has been taken place, how we can compare the results, can we learn something new from this. Indeed, what has been then identified that what would be very nice is if we could add one more important leg, not only just the different parts of material science, of synthesis, doing experiments and calculations, but also providing a digital infrastructure which connects all of these things together. And that's what basically what FAIRmat is about. As a previous results, we already have data storage, which contains more than 100 million of different computations. These are mainly simulation results, which are coming from theory. But slowly we are getting also experimental data in, and indeed that's where also HDF comes into play. What is important is that we would like to have all the data also annotated. So then we can really have algorithms which can just go there, select all the compatible data from this big data lake, and do things like machine learning and other kind of stuff, which is already heavily used by the community. And we already have an artificial intelligence toolkit. So the idea is to use modern technologies, Python backend, JavaScript, React frontend, and all the other stuff which is needed for gluing the whole thing together and making it running in a digital infrastructure. What is also important is that we are also supporting workflows. So that means that when someone uploads the data, then it's not just the data store, but we automatically go through on the data, we interpret the data, what's inside, and we categorize it, we put it into an encyclopedia, so then it really allows later the search in the whole the database. What we are doing right now, as a new project, we are setting up a new data center in Berlin, where we will also would like to see how Nexus data can be then integrated into this infrastructure. So Nexus integration is one of the things where we would like to cover electron microscopy, angle resolved photoemission, core level spectroscopy, optical spectroscopy, as well as atom probe tomography. Indeed, this data center is being built now, and we are looking for anyone who has experience in programming or material science, and we are welcoming anyone. Thank you for your attention.
Thank you very much. And we have a few minutes for questions. It's late for Europeans, and it was too early for this side, so people probably a little bit tired.
No problem. I can repeat. If you would like to come to Berlin, please join us.
Thank you. If there are no questions, first of all, once again, chat window, if you come up with a question. So